Now again we are going to have the differentiation of inverse trigonometric functions, but we are taking here cosec inverse x, sec inverse x and cot inverse x one by one. So first we are going to have the derivative of cosec inverse x or arccosec x. So let y equals to cosec inverse x. So that means if y is cosec inverse x, then x is equal to cosec y. Now we will differentiate both sides. So the differential of x with respect to x and differential of cos y with respect to x, left side and right side, we will be differentiating. So differential of x is 1 and differential of cosec y equals to negative cosec y cot y, and for y dy by dx. Therefore dy by dx will be equal to minus 1 by cosec y cot y. So we will express everything in terms of x for cosec y and cot y. So let us change this. So using cosec square y equals to 1 plus cot square y. So we will be getting, we need to get the value of cot y in terms of x. So, and cosec x is already equal to x. So there we don't need to do anything. So that means we are substituting x equals to cosec y. We shall be getting x square equals to 1 plus cot square y, or cot square y equals to x square minus 1. That means we will get cot y equals to root under x square minus 1. Thus dy by dx equals to minus 1 by cosec y cot y, which is equal to 1 by x root under x square minus 1. Since the account for both positive and negative value for x, since it is a absolute value, so we were getting x positive and negative, so we will show the absolute value of x. So finally we get d dx of cosec inverse x equals to minus 1 by absolute x root under x square minus 1. Now in the next we are going to have the differential of sec inverse x or arcsec x. So if y equals to sec inverse x, then x is equal to sec y, and we will differentiate both sides. So differential of x is 1 and differential of sec y is sec y tan y, and differential of y is dy by dx. So we will have dy by dx on one side and rest other things on the other side. So we get 1 by dy by dx equals to 1 by sec y tan y. And dy by dx is nothing but it is d of sec inverse x by dx. So expressing everything in terms of the x, we are having sec y equals to x, that we have assumed in the beginning. And we know that sec square y equals to 1 plus tan square y. So x square is equal to 1 plus tan square y. And then we can have tan square y equals to x square minus 1. And so tan y equals to root under x square minus 1. Since we are having dy by dx equals to sec y tan y, so we need to know the convert the value of sec y in terms of x. That we have already assumed that it is equal to x, and tan y we have to also convert into terms of x. So we get here tan y equals to x square minus 1. Substituting dy by dx equals to d of sec inverse x by dx, which is our prime requirement, and we get is equal to 1 by sec y tan y. Now sec y is x and tan y is root under x square minus 1. So we get our d of sec inverse x by dx equals to 1 by x root under x square minus 1. So using the absolute value, we are getting d of dx, d dx of sec inverse x equals to 1 by absolute x times root x square minus 1. Now next we are going to have the inverse different trigonometric function derivative as y equals to cot inverse x or arccot x. So if y equals to cot inverse x, then we are getting x equals to cot y. And while differentiating both sides, the differential of x is 1 and the differential of cot y is uh, equal to minus cosec square y dy by dx. So we are getting 1 equals to minus cosec square y dy by dx. So dy by dx will be equal to minus 1 by cosec square y. Now we will try to express everything in terms of x. So cosec square y has to be converted into x. Since we have cot y equals to x, so we will correlate the cosec square y with cot square y. And we know that cosec square y equals to 1 plus cot square y. So cot y, since cot y equals to x, so we can say that cosec square y is equal to 1 plus cot square y. So we can say that it is cosec square y equals to 1 plus x square. So differential of cot inverse x by dx is equal to minus 1 by cosec square y, which is equal to minus 1 by 1 plus x square. Finally, we get our differential of cot inverse x with respect to x equals to minus 1 by 1 plus x square. Now, summarizing the results, we get a differential of cosec inverse x by dx equals to minus 1 by absolute x root under x square minus 1. The differential of sec inverse x by dx equals to 1 by absolute x root under x square minus 1. And differential of cot inverse x with respect to x equals to minus 1 by 1 plus x square. This video ends here. We request the viewers to like and share these free videos among friends and others. Also subscribe to the channel SS Academy in and press the bell icon to get notification for upcoming videos. My name is Syavar Srivastava. Anyone willing to have one-to-one interaction for details about our life, math and physics classes can contact us on our WhatsApp numbers 919972524525 or 918217238636. Thank you.